What is up? We are on Unit 9, Section 1, Graphing Exponential Functions. So 3 goals for today: to graph exponential functions, identify asymptotes, domain, and range of exponential functions, and identify if a graph is exponential growth or decay. So here we go, the graph of exponential functions. If our b values, take a look at the generic equation here. We have an hk value again, which is going to help us out with our shift. We have b, which will tell us growth or decay. We have our a value that'll make it grow really quick or really slow, or decay really quick or really slow. The stretch or shrink would probably be a better way. But here's how you tell really quickly if you have growth or decay. So you're going to look at your b value, okay? If your b value is greater than 1, so for example, 2, 3, 20, so on, 1.5, you have growth. If your b value is less than 1, so something like 1/2, 4/5, 3/4, so on, you're going to end up with exponential decay. Again, a is the vertical stretch or shrink, and that word asymptote's back again. That is just an imaginary line that our graph cannot cross. So let's jump into graphing. So it says graph the function f of x equals 2 to the x power. So first of all, let's identify our shift. Our shift comes from h, which is any number up by the exponent, and k, which would be any number behind our equation here. So if you look, h would be up here. There is none, so it would be 0. K would be back here, but it is none, so it is 0. So take a look at our b value quickly here. Our b value is 2. 2 is bigger than 1. We have exponential growth. We'll talk about domain and range here in just 1 second. All right, so for our table, what we want to do is probably just stay with the same 5 values. I'll give you the same 5 values here that I'm going to use always throughout this section here. So I'm always going to pick -2, -1, 0, 1, and 2 just to make my life easier. And what you're doing to those is you're plugging them into your function f of x equals 2 to the x power. So the first one would be 2 to the -2 power, which means you'd have to flip it down, so it'd be 1 over 2 squared or 1 over 4. The second one would be 2 to the -1. If you follow the same process, you get 1 over 2. This one would be 2 to the 0 power. Anything to the 0 power is 1. 2 to the first is just 2, and 2 squared is 4. The last column, just like before, would be a times y. We have an a value, but it's just 1. So 1 times that y column, or f of x column. Remember, f of x and y are the same thing, whatever you want to call it. So in this case, we'd be taking 1 times all those values. So this would just be 1/4, 1/2, 1, 2, 4, because my a value again here is 1. So I am actually going to scribble out the middle just like before. You use that middle column to get to the last column, and then you plot those points from wherever your shift is at. So our shift is here at the origin 0, 0. So from 0, 0, I'm going to plot this first point right here, which tells me to go left 2, up 1/4. So if I go left 2, up 1/4, it puts me like right about there. It's hard to plot 1/4 accurately on a little graph like this, but do the best you can. Now my next point here tells me to go left 1, up 1/2, so about right there. The next point is 0, 1, so I'm not going left or right, but I'm going up 1. Oops. Fourth point tells me to go to the right 1, up 2. And you can see all of a sudden here my graph is starting to take off. And the last one, go to the right 2, up 4. And here is our graph. So, like we said, we had exponential growth. Our shift, we did not shift. That is a normal exponential function. So the last few things here, the domain and the range. The domain are the x values that you can plug in. And because it's an exponential function, there is no limit, so you can plug in all real numbers if you'd like. The range, though, we're only allowed certain values, and this comes from our asymptotes. Let's talk about that. Asymptote's that line that we cannot cross. It's kind of hard to tell because my drawing's not the best, but in this example, my asymptote is the line y equals 0. That's this line right here. I will never cross that graph. You can keep plugging in values, you can keep trying, but I will never go below 0 as far as an output. Also, another thing of note, it's always your k value. So go ahead and highlight that. Your k value here was 0. My asymptote was 0. And because I can never get below 0, my range would be y is greater than 0. Not greater than or equal to, because we can never actually get to 0. But it's always going to be everything above 0. All right, let's try another one. So let's start with the shift. So h is up here, there is nothing. K is back here, there is nothing. So our shift is 0, 0, so we're starting from the origin again. My b value is 2. 2 is greater than 1, so this would be growth. Now it's going to look a little funny here, and I'll show you why in a second. And I might as well enter the domain here. X is, you can just say all real numbers. Let's do it like that. All real numbers. There's no limitations here for these exponential functions. For my table, we'll go -2, -1, 0, 1, 2. And when you plug these in, you're just going to take the most basic part of your function. Ignore a, ignore h, ignore k. You're just going to take the base, or b, raised to the exponent, and you're going to plug those 5 values into that function. So we actually did this right up here. So we have the value. So 2 to the -2, I'll write it one more time, is a fourth. 2 to the -1 is a half. 2 to the 0 is 1, 2 to the first is 2, and 2 to the second is 4. The last column again says take a times y, because remember f of x and y, it's the same thing. So you take your a value, which we actually have this time, it's -2, times that y column. So 1/4, I'll do this off to the side here, 1/4 times -2 is -2/4, or -1/2. All right, I'll erase that. I'll do it again here for fractions, because sometimes they can be tough to see. So 1/2 times -2 is -2/2, which is -1. Now this should be pretty easy. 1 times -2 is -2. 2 times -2 is -4. 4 times -2 is -8. Again, once you get these values, just kind of scribble out that middle. We're done with it. It was just a stepping stone to get to that last column. And then from our shift, which is 0, 0 here, I'm going to put a point, but it doesn't really affect my graph. I need to plot these points. So from there, I need to go left for this point right here. Left to down 1/2, something like that. For the second point, we're going left 1, down 1. That one's pretty easy to graph. The third point would be 0, -2. Fourth point here would be 1, -4. And the last point here would be 2, -8. So something like this. So it is exponential growth. It's just going in the negative direction. So let's talk about the asymptote again. You can kind of see it's creeping ever so closely to y equals 0 again, but it's never going to cross. And because it's never going to cross, and because we're below it, that means we're never going to get above it. So our range is going to be y is less than 0. Again, these numbers come from my k value. My k value here was 0. So that's where those numbers come from. And then all you have to do is decide, I don't use that. So all you have to do is decide, is it going to be less than 0 or greater than 0? The asymptote is always equal 0 or equal whatever number. So let's try one here with a little bit of a shift. So again, start by identifying h and k. Well, h is up here, so it's nothing, 0. K is back here, so it is 2. So 0, 2 is my shift. And what you're going to do right away once you actually have a shift is draw in a nice horizontal line. That is our asymptote. We know it is y equals 2, our k value. This is going to be exponential decay, because here is my b value. It's 1/2. 1/2 is less than 1, so that means it is going to be decay. Domain again, all real numbers, not going to change. And then we'll got to decide if we're going to be coming down like this or going up like this. We have one of those two options, so we'll wait for our range. We know it's going to be y is something compared to 2, though. We don't know if it's greater than or less than. All right, the table, same 5 values, -2, -1, 0, 1, 2. Now, this time when you plug them in, it's going to be to this function, 1/2 x. Again, you ignore everything else. You just focus on the basic function that you're given. So now we have 1/2 to the -2 power. So you'd have to flip the fraction, so it'd be 2/1 to the +2. 2 squared is 4. The next one, so we have 1/2 to the -1. Again, you flip it, then you get 2 to the first, which is 2. 0, excuse me 1 second here, 0 to, or 2, 1/2 to the 0 power, my goodness, is, oh, what's going on here? All right, 1/2 to the 0 power is just 1. Anything to the 0 power is always 1. And then here it gets easier. 1/2 to the first is 1/2. 1/2 squared is 1/4. Square the numerator, square the denominator. And your a value is just 1, so you get 4, 2, 1, 1/2, and 1/4. There you go. Now you're plotting these points from our shift, which is 0, 2. So that means from my shift, I need to go, left 2, up 4. Go back to the middle of my shift there. We're going to go left 1, up 2. And you can kind of see the general shape. 0, 1. To the right 1, up 1/2. To the right 2, up 1/4. So you can kind of see it's declining now. Going forever that way. So now we got to decide my range. Is it y is less than 2 or y is greater than 2? Well, because we are above our asymptote, we want to say that y is greater than 2. So see if we can find a good example here with a h and a k shift. So I'm going to skip example number 5. Let's go right to example 6. We have a, we have h, we have k, we have everything we could ever want in a problem. Lucky us. All right. So first of all, let's identify the shift. So we have h here. Now the thing about h is that you have to switch the sign, just like most situations. K, you leave that value alone, leave that sign alone. So you still look here at b to identify growth or decay. 1/3 is less than 1, so we have decay. My domain, all real numbers, that's not going to change. My asymptote always comes from k, so we would say that y equals -3. So if I plot my shift really quickly, I'll draw a point there and I make a horizontal line through it. There is that asymptote. All right. What am I missing here? Sorry. We want to fill out a table. Yes, we want -2, -1, 0, 1, and 2. So we've taken care of everything. So when we plug these values in again, all you have to do is focus on the bare minimum. So 1/3 to the x power. We'll take care of a here. We took care of h and k with the shift. We're done with that. So you take 1/3 to the -2 power. So I'll do it over here. 1/3 to the -2. You flip the fraction. 3/1 to the +2, which is 3 squared, or 9. 1/3 to the -1. Same thing. You gotta flip the fraction. Now it becomes 3 to the 1st, or 3. Anything to the 0 power is 1. 1/3 to the 1st power is 1/3, and then 1/3 to the 2nd power. You square the numerator, you get 1. Square the denominator, you get 9. Now here, like I said, we have everything we want. We have an a value this time. So now we have, let's pick a different color. -2 times that y value. All those y values we just wrote down, now we got to multiply them all by -2. So 9 times -2 is -18. This would be -6. This would be -2. This would be -2/3. And -2/9. So just like before, you treat this point right here as your origin. You're going to plot all of these points from there. So I'm done with this. So from there, we're going to go left 2 down 18, because why not? Do the best that you can. We know it's going to be like somewhere way down here, so probably not necessary for our graph. We'll see if we can get the idea of it from the rest. So the second point here, we're going to go left 1 down 6, 2, 4, 6. Right here, we're at 0, -2. Again, these all come from my new origin point right here. Now from there, I'm going to the right 1 down 2/3. So that would be somewhere right about here. And my last point, right 2 down 2/9. So something like that. When you start getting into those fractions, just do the best you can. We're just trying to get the general shape here. So like we said, our asymptote is at y equals -3. My range is going to be y is what compared to -3? Because again, that always comes from our k value back here. Because we are below, we would say that y is less than -3. So there you go. There is one more example. Example number 7 with an a, h, and a k value. I would give that a practice. Just remember, with h, flip the sign. K, leave the same. And if you want to jump back here to example number 5. But that is